Hello everyone, welcome for this lecture. In the previous class we have discussed the power angle equation of non-salient pole synchronous machine. Today we are going to deal with the power angle equation of a salient pole synchronous machine. Okay, as we have seen a difference between those two in the construction as well, the salient pole machines has a number of projecting poles. Okay, hence air gap is non-uniform along the rotor periphery. Okay, it is a least angle the axis of the main poles, it is called as direct axis, and the maximum along the axis of interpolar region is called as quadrature axis. Hence the flux linkage is non-uniform. Okay, here we cannot take a synchronous reactance as axis, right? It has to be like, you need to consider xd and xq. Okay, so these are all like, the machines offers the direct axis reactance and quadrature axis reactance for the flow of armature current. Therefore axis has to be taken xd and xq. Okay, therefore your emf equation comes like this. Okay, emf equation will be like, terminal voltage, that is infinite bus voltage, plus iq xq, means since it is a quadrature axis reactance, there will be a quadrature current, and then id xd. Okay, this you have to consider. So based on this circuit diagram, means to draw the a model of the machines cannot be done easily, but a phasor diagram of the machines can be can be drawn by neglecting its armature resistances. Okay, we'll do how it can be done. Okay, so observe carefully. This is v as be taken as a reference. Okay, so if you take a reference, this will be your v. Okay, as we have assumed this is an inductive system, then I lags voltage, infinite bus voltage by 5. Okay, as we know, this current resolves into two parts. Okay, quadrature axis and your and your direct axis. This is your iq and this is your id. Okay, and the next is when you are taking v iq xq, remember iq and id xq. First we'll take id xd, that is nothing but this is the voltage drop. Okay, anyhow it is the voltage, right? So this voltage has to lead id by 90 degree. Okay, so id is there, draw a perpendicular line for this with respect to this line. So when you are drawing perpendicular line for this, it will be like this. Okay, so we have drawn this line perpendicular to this id. Okay, just drawn perpendicular to this id. And next when you have taken, okay, neatly also you can draw, I'll show you again. Okay, so this has to be drawn perpendicularly. And the next is the iq xq. Okay, iq xq means what? For iq we have to draw perpendicular line. Okay, and then this is a total your induced emf, that is v plus idxd, and this is your xq into iq. Okay, this total is your e, which makes an angle delta with respect to your v. Okay, now we need to calculate that what is your e and all. Okay, I hope it is clear to you. V, it is current I, right? I is changing, means resolving into two components. Okay, horizontally and vertically. Horizontal one is iq and vertical one is id. Okay, and then along with this v, what we have to do is we have to take a equation of e. When you are taking this, it will be like, iq xq as well as your id xd, right? id xd, when you would like to take, it should be perpendicular to this id. So this is your id xd, means a voltage drop. Okay, which is leading current by 90 degree. And then iq xq has to be taken perpendicular to this line. Okay, this is your iq xq, right? This is your total e, which makes an angle delta. Now we need to find out what is this e is. Okay, so let's see this. I hope you are clear with now. So more clear with this. Okay, this is your V, right? And then this is your I, which makes an angle phi between these two. Okay, and this resolves to two components IQ and ID. All right, and then from this to get a IDXT first and IQXQ. So this I'll speak later. Okay, so IDXT and IQXQ. IDXT is perpendicular to this line, and then IQXQ is perpendicular to this line. Okay, and then total this one is your E. Now we'll define each term. To calculate total E, what we have to do is V, from this V take a perpendicular line. Okay, and then next, total E, let's take this as O. You can take A, and this you can take B, and this you can take a C. Okay, so now to calculate E, E is nothing but your OA, right? E is nothing but your OA. Next, this can be split up into OB plus BA or AB. Anything you can take, right? Now this one you can observe, this one is nothing but this term, right? Is both are same, is nothing but your xt id idxt, right? Ba is your xt into id. Now we need to calculate what is this ob. So what we have to do is observe this triangle, that is we'll take this as c. In a triangle ocb, okay, in a triangle, okay, oh no, in a triangle obc or ocb, okay, define, this is, since it is angle delta, right? This is angle delta. Define cos delta. Observe for this angle, so this is your opposite and this is your hypotenuse, this is your adjacent. So we require adjacent, therefore which angle should be defined? Cos delta. Cos delta is adjacent divided by hypotenuse. Hypotenuse what? V. Hypotenuse is V, so we require adjacent, which is equal to V cos delta. Okay, so then this term will be, this part will be your V cos delta. Okay, and next, so since it is a V cos delta, this is a delta angle, so this angle is also delta. I hope you are good with geometric, so these two can be equal. Okay, and then what you have to do is define in this triangle, we require this one, means for this angle, this is opposite, so we require opposite angle, means opposite part. Then what we have to do is define sine delta, which is equal to opposite divided by hypotenuse. What is hypotenuse? It is V, so therefore opposite will be what? V sine delta. Okay, therefore this is your V sine delta, right? This is V cos delta and this is a V sine delta. Remember, in this phasor diagram, this V sine delta is nothing but your IQ XQ, means both are same, means both are equal. Okay, right? And then what we can define is, from this phasor diagram, as we are familiar with this, we can take E at an angle delta. Let's take E at an angle delta is generator EMF of the synchronous machine. V at an angle 0 is the bus bar voltage, as we have taken as a reference. Xt is the quadrature, direct axis reactance. Xq is the quadrature axis reactance of the synchronous machine, and I is the current delivered at a lagging power factor, okay, of cos phi, right? By this phasor diagram, we have to write power delivered, power developed as P is equal to, you can write P is equal to IQ V sin V cos delta, because this is the power, plus ID V sin delta. Okay, V cos delta into IQ. Okay, and then V sin delta into ID. Okay, let's call this equation number 1. In this equation, we need to substitute the value of IQ and ID. We need to calculate, and then we need to express, means substitute in this equation. Let's calculate what is IQ and what is the ID. Okay, let's, as we have said in this phasor diagram, you can observe IQ XQ is equal to V sin delta, right? That equation you have to take. IQ XQ is equal to V sin delta. So therefore IQ is equal to V sin delta divided by XQ. Let's call this equation number 2. And next, we require this part, right? That is idxt, which is equal to what? This term, this part. But we know total part is E, right? What is this part? Is V cos delta. Then what about this part? A part is V minus V, sorry, E minus V cos delta. Okay, that you can substitute. So id xt is equal to E minus V cos delta. So therefore id is equal to what we can take, E minus V cos delta divided by xt has to be done. Okay, therefore these two equations, second and third equation, has to be substituted in this equation. Okay, let's substitute. V cos delta was there, this is your iq plus this is your id in that equation. Now just to simplify, v into v square sine delta into cos delta divided by xq, right? This, there are two parts, so expand each part. Okay, v into e is sine delta, right? V into e sine delta divided by xt, and then this has to be multiplied with this factor also. Therefore it should be like, this into this, then it is v square sine delta into cos delta divided by xt. Okay, so now this express sine delta into cos delta as sine 2 theta formula we know, right? It is nothing but 2 cos theta into sine theta. If sine theta cos theta is equal to what? Sine 2 theta divided by 2, that we can take. So it is nothing, this sine delta cos delta can be written as sine 2 delta divided by 2. So the same equation, this part is also replaced by this one. Okay, and now in this equation take these two equations. Among this, which all the terms are common, you just take outside. It is v square sine 2 delta divided by 2. If you take outside, it will be 1 by xq and 1 by xt remains inside. Okay, plus this term as it is. We'll take this term first. Okay, term this first, and then this term is kept second. V square sine 2 delta divided by 2 into this, just a simplification if you have done, it will be cross multiplication and LCM, xt minus xq divided by xt into xq. Okay, therefore power equation can be given as like this. Okay, same thing, just we have written a systematic manner. This is your power angle curve, sorry, power angle equation. Okay, your second from this equation, second term indicates your fundamental second harmonic component is present. By observing that equation, we'll come to know, right? um, as the first term is the same as that of your non-salient pole machine. Okay, just is xs is equal to xt there, right? This constitute the major part of the power transfer. Okay, then the second part is quite small compared to the first term. Okay, how much it will be small? It is around like 10 to 20% small compared to your first term. Okay, and this one is known as reluctance power. Okay, so let's draw its power angle curve of this. Okay, let's draw its power angle curve. So this one is see, this one is your first part. Okay, this one is first part power. Okay, this is your second part power, that is a reluctance power. Okay, this is a salient pole machine power. Okay, that is, sorry, you can mention it as non-salient power or first part of the power, and then this is a reluctance power, and this one is a maximum power. Sorry, means resultant power of the total both. Okay, so just observe, in your resultant you are getting a maximum power. Okay, you are getting maximum power not at 90 degree. Okay, you can observe, not at 90 degree, you are getting less than 90 degree. Okay, less than, at less than 90 degree itself you are getting a maximum power. Okay, this can be calculated, how it has to be calculated, it is around like 65 to 70 degree at there only you get a maximum power. Only thing is how to calculate this is you can compute it by equating the synchronizing power coefficient to dp, that is the dp by d delta equal to 0. Okay, if you do this we'll get to know. We'll see this in detail in the next example. Okay, so thank you.